So, hello guys, with the name of God, Ram Ram, let's start this session. I have observed at many places on very different LinkedIn posts, LeetCode posts, YouTube videos. No one is explaining this particular problem with the deep feeling and intuition. They are just explaining the algorithm. So, just explaining the algorithm is not enough. If you don't explain your student how to come up with the solution and why are we doing what, your student is never going to improve. And that's the sole reason why I have daily 10 plus LPS selections of my students and others don't have. So let's focus on this problem. The problem is saying that for we are given an array. For each window of size k, we have to find the maximum element. Okay, let's do some basic stuff. So what will be the answer for this array? Let's say my sliding window is of size k and k is 3. So for all the sliding windows of size 3, I need to find the maximum number. So the first sliding window is 532. What is the maximum of this? 5. Second sliding window is 328. Second sliding window is 328. Okay. What is the maximum of this? 8. Third sliding window is 281. Third sliding window is 281. Third sliding window is 281. What is the answer? 8. Then another one 814. Answer is what? 8. Another is 143. What is the answer? 4. Another one is 432. What is the answer? 4. So 5 888 4 is the answer to our problem. In the question, we will be given an input array and k, and we have to find the answer. The brute force solution is very easy. For each index I, what you can do is iterate from I to I plus k and find the maximum of it. And like that, you get the maximum for all the sliding windows. Okay, that approach is basically very easy. Okay, I have a for loop here. My I is say going from 0 to n minus 1. Okay, then I pivot. Okay, my start point will be what? I. My end point, I will make it as I, and I will run a for loop where my end point will go from I to I plus k minus 1. Okay, so basically I is the start point of that sliding window. And for example, if this was my I, let's say this was my I. Okay, this was my I, start point of the sliding window. So I can go three places ahead now. One place, two place, three place. So my I s equal to I, the start, it is the start position of the window. Start position of the window is 1. So I will go from here till three places ahead. 1 4 3. So if I go to 1 4 3, you will find out that the maximum of them, 1 comma 4 comma 3, maximum of them is 4. So that's all that I'm doing. My I, which is I is going from 0 to n minus 1. I is nothing but the start pointer of the window. Now the window is of size k, na? So from this start pointer, I am going k places ahead. I is going from I to I plus k minus 1. Then I find maximum of all the elements here. That maximum is the answer. For each index I try to print the maximum. Also, there is one more interesting observation which you can do, guys. That let's say if our k was 1, say our k was 1, then yes, our I should have gone from 0 to n minus 1. But what if k is 2? Then it should go from I equal to 0 till I equal to n minus k. I equal to 0 till I equal to n minus k. Okay, because it is common sense. For example, here the k is 3. So at last your start pointer can only go from 5 till 4. Okay, because if you start from 4, your sliding window will cover the entire last thing, 4 3 2. But if you start from 3, then that's wrong, because there are not 3 elements after 3. We need at least 3 elements, right? So we are going till n minus k, n minus 3. I is going from n minus k, n minus 3, which is where k is equal to 3. This is n minus 1. See, this black is n minus 1, this is n minus 2, this is n minus 3, and this is index 0. Okay, we are iterating from index 0. So this many basic concepts are clear to everyone. Okay, good, great, nice. Now, the time complexity, see, you are going from 0 to n minus 1, it takes O of n time. And for each index I, you are using a nested for loop. You are going from I to I plus k minus 1, which roughly takes k operations. So O of k time for each index I, so it takes n into k time, which is not efficient. Which is not efficient for this problem. Before we go towards the efficient solution, I want to introduce a very special data structure to you people. It is called as deque. This special, very special data structure close to my heart, it is called as deque. So deque is nothing but just a container. You can push any element at the back of the deque or at the start of the deque. Let's say you have a deque, okay, G. This is my deque. Someone says push front pf, push front phi. So phi, I will push it in the front, it will look like this. Someone says push back 8. 8 I will push at the back, it looks like this. Someone says push back 10. I will push 10 at the back, it looks like this. Say someone says push front 11. Push front 11. It means push 11 in the front. So basically guys, I hope you got the idea of this data structure, that you are given a container. If a person comes and tells you that push this element at the start, you will push that element at the start. If some person comes and tells you push that element at the end, you will push that element at the end. Just like pushing removal operation is also there. If here someone comes and says you remove 11 from the start, so q will look like this, deque will look like this. Someone says remove 10 from the back, deque will look like this. So what you can do in a deque na is that you are given this container, you can push any elements you want at the start, you can push any elements you want at the back, you can remove any elements from the start, you can remove any elements you want from the back. That's it guys, that's it. Congratulations. Now, I want to go with you in the very deep ocean. Okay, let's go in the deep ocean, very deep ocean. People are only explaining the algorithm, not the why. I will explain you the why today. Okay, so guys, let's consider that whenever I have an array now, let's say we are considering this sliding window of size k. Okay, so all the elements in this sliding window now, I put them in my container deque. Okay, they are in my container deque. How does my deque look? How does my deque look? My deque is in sorted in descending order. The first element will be the largest one, then the element will be like this, then it will be smaller. That's it. So for example, if my array is like this, okay, say my this is my k, okay, k is 3. I am considering this sliding window of size 3. So how will my container look guys? My deque container, first element should be the largest one, 5 here, then the little bit smaller guy 3 here, then little bit smaller guy 2 here. So guys, I assume that now you understand what I am going to do now. For each sliding window of size k na, I will be having my container. I call it as deque, but let's call it as container. In the container there will be most of the elements, there will be some elements from this sliding window of size k in strictly descending order. Strictly descending order. Got it guys? Strictly descending order, and the first element will be the largest, last one will be the smaller one. Okay, first element will be the largest element of this sliding window. Now guys, the trick is that for each sliding window, for each sliding window of size k, for each sliding window of size k, make a container which has all the elements in strict in decreasing order. Obviously, the first element will be the largest element of the container, as well as the sliding window as well. So guys, always remember that for each sliding window of size k na, I make a container which has some of the elements of that sliding window all in the decreasing order, and the first element is the largest element of that sliding window, and rest all are smaller. Now the question is, how are you able to make such container which is able to achieve these things? So let's get into it guys, let's get into it. So the thing is that we will come to why and what very soon. First, I want that the structure should be clear to you, that what I'm going to do now is that for each sliding window, whatever elements are in that sliding window now, I will push them magically into my container. My container will have the largest value at the start, and slowly values will start decreasing. Now guys, I am introducing the second property of the container. All elements in the container follow the original ordering of numbers given in the array given in the array given in the array. All elements in the container follow the original ordering of the numbers given in the array. Original ordering. Basically, if 5 is here and 3 is here, then it is guaranteed. Then in the original array also 5 comes first, and then only 3 should come. If 3 is coming, then 2 is coming, then in the original array also 3 should come, then 2 should come. For example, let's say we had an array like this, okay? 5, 1, 3, 0, 2, okay? There are many elements, okay? There are many elements. I am not considering all the elements. I'm just considering the numbers which I have written. And let's say our sliding window is of size 5. K is equal to 5. So how will my deque look for this? How will my container look for this sliding window? The biggest element should be at the start, 5. Then just take whatever elements you like. Okay, just take whatever elements for now in the decreasing order. So you write 5 here. Let's say you want to write 3 here, and then you write 2 here. So what does this mean, guys? What does this mean? That 5 is, see, I have one thing I have maintained, that it is in strictly decreasing order, and the first number is the largest number of that sliding window, because you always want the largest number. But there is a trick. I have written 3 after 5. It means 3 is for sure coming after 5 only. I have written 2 after 3. It means in the original sliding window also 2 is coming after 3. Guys, please get what I am trying to say. I am saying that for each sliding window, we will magically create some container which will have some of the elements of that sliding window in decreasing order, and the first element will be the largest guy. But there is one more thing, that all the elements in our container should follow the same ordering as in the original array. In our container, I am writing 5, 3, 2. It means 5, 3, 2 should be in this order only here also. It should not happen that here there is 5, 2, 3. It should be 5, 3, 2 only. After 5 there should be 3. After 3 there should be 2. That's it guys. That's it. Great going guys, great going guys. Nice. Now I will explain the intuition behind these things. I can guarantee that in the whole country no one is going to explain you like I am going to do it for this problem. That's why I'm very fortunate to God that he made me Kumar K and gave me the power to serve all of you people. Now, guys, let's say I had this large array. Okay, okay, and this is 5. There are some elements in middle. I'm ignoring them. This is 3. This is 2. Okay, and consider we are currently considering the sliding window for this array of size 4. K is equal to 4. K is equal to 4. Okay, 1 2 3. Okay, K is equal to 5. Sorry, K is equal to 5. K is equal to 5. Even legends can do mistakes sometimes. K is equal to 5, guys. K is equal to 5. Now, if you just randomly want to make a container for it, how will the container look? First number for this sliding window I'm considering now. First number should be the largest number of the sliding window. Let's assume the elements which I did not write, they were very small. They were means they were smaller than 5 for sure. So what would I write in my container in decreasing order? 5 is the biggest guy, then 3 the smallest guy, then 2 the one the smaller than 3. Now, guys, in the algorithm, now you want to print which is the maximum element of the sliding window. So, guys, algorithm is very simple. First element of the container, first element of the container is always the maximum element. Okay. Now, algorithm I'm trying to write for you. Algorithm, so simple. It is guaranteed that I am making everything in descending order, and the first element is the largest one, so that will only be my answer, na? Algorithm. First element of the container is always the largest element and our answer. Okay, it's fixed. So for this sliding window, answer will be 5. For this sliding window, answer will be 5. Okay, for this sliding window, answer will be 5, guys. Answer will be 5. Okay, let's say there was a 4 here. Okay, okay. So you only use your brain that there is a 4 there. Okay, now I am shifting my sliding window by one place. Shifting my sliding window by one place means you come at this particular index and you see that a 4 is there. You see that there is a 4. You see that there is a 4. You see that there is a 4. Okay, okay. So the thing is that you see that there is a 4. And this 5 got removed. This 5 got removed. So, guys, what should you do in the deque? In the deque, now you should have the indices of all the numbers which you are putting. 5, 3, 2. You should know what is their index. You should know what is the index. Okay, when you are say at this index I, you are at that index I. So let's say this was I minus 1, I minus 2, I minus 3, I minus 4. If the first element is having the index of less than equal to I minus k, if it is having the index of less than equal to I minus k, means this is not the part of our window. We should remove this element. We should remove this element. So, guys, this should be very easy to you. This is very like this you can feel na, that this was my sliding window. Okay, I store the elements in the queue 532. Okay, but when I go ahead now, I see that now I have to put another element in my container, which is 4. But what is the index currently? I. So I will check whatever is the largest element in my previous container. What is its index? Is its index less than equal to I minus k? If yes, it means it is not part of our current window. Remove this stuff. So I will remove the element from the start of the container. Okay, so basically when you hit a new index I, when you hit a new index I, organically you should check the old container first element. First element, you should see if its index is less than equal to I minus k. If yes, it means this guy cannot be the part of current sliding window. So please remove this guy. Please remove this guy from the start. You repeat the guys, you will keep on doing this until you remove all the non-usable guys. So you remove 5, it looks like now 3 and 2. Now you check 3. Is 3 less than equal to I minus k? K is 5 here. No, 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 no. 3 is not less than equal to I minus k. 3 is actually the part of the current sliding window from question mark to 4. So you stop the removing process. So guys, can you see? I intuitively explained you organically that whenever you are going ahead, whatever is the first element in your container, you should check its index. Is it worthy of being in my sliding window? If it is not, remove it. Then you check the current largest guy. You keep on removing the guys from the start. You keep on removing the guys from the elements from the start, which are not valid, which are not valid. Once that is done, once that is done, you pick your new element at index I and put it at its correct position, So guys, you remove that. Now how does it look? It looks like this, na, 3 and 2. Now 4 comes. 4, I want to add 4 in this container in such a manner that the the container remains sorted. So I will put a 4 ahead, na, 4 3 2. Got it, guys? Got it, my lovers? Did you get it? That once you are done the removing part, now the current element is coming, na. We have to insert this current element somewhere. We have to insert it somewhere. We have to insert our current element. So whatever is now left over, na, I will insert my current element at the correct position so the container remains sorted. Okay. So now let me take a different test case to explain this to you in a better format. Let's say, okay, let's say my k was of size 5. Okay. What would my deque look like? It would look like this: 5, then 3, then 2. Guys, I am keeping some elements empty. Huh? You just imagine that they are very, very small numbers. Okay. They don't matter to us. So 5 3 2 would be my deque. What would be the answer for this? The first element of the container. But when I go one step ahead, from here to here, I go one step ahead. Okay. I go one step ahead. I go one step ahead. Then what should I do? First, I should see, is this first element valid anymore? Is the index of this biggest guy less than equal to I minus k? Because I need to check, is this element valid? Will it remain in my sliding window now also? So I check 5. 5 ka index is what? This. My current index is this I. This is I minus 1, I minus 2, I minus 3, I minus 4. This is I minus k. So no, 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 no. 5 is valid. 5 is not less than equal to I minus k. And you can see that with your eyes. 5 is in this sliding window as well. So it should be considered. So you will not remove your 5. Once you have checked what to remove, what not to remove, now comes the addition part. This 4 is there, guys. This 4 is there. This 4 is there. Now what will you do? What will you do? What will you do? I will insert this 4 in this container towards its original value. Where should it come, guys? Where should it come? Use your brain. Where should it come? It should come here. 5, 4, 3, 2. I use some trick and I insert it at its correct position. I'm maintaining the sorted order. Then what do I do? Whichever elements are greater than or greater than 4, na? Greater than 4. I remove them. I remove them. And now my DQ looks like this only. All the elements, not greater than 4, sorry, less than 4. All the elements less than 4 I remove. All the elements less than current guy being pushed are removed. At back, pushed at back are removed. Now no YouTuber will explain you why. Why did I do this? Why did I remove the previous guy? Why? 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 Why did I remove 3 and 2? Guys, now I will get into your feelings, okay? So you, acha, first of all, calm down. Now my container looks like this, 5 to 4, right? So what will be the answer? The first element of the container, 5. So yes, 5 is the biggest, 5 is the biggest element of the sliding window. We found it correctly. But why did I remove 3 and 2? Because it is guaranteed that they will not be required again. 3 and 2 will never be required again. I can explain that to you with the live proof. Okay, live proof. So in this sliding window, you only keep 5 and 4 with you and you ignore the 3 and 2. You remove them. Why? Because you think of the future. 3 and 2 will not be required in the future sliding windows. Why? Because you already have 5, you already have 4. Now, if you take one step ahead in this sliding window, largest guy 4 is already there. 4 is already there, guys. 4 is already there. So 3 and 2's turn will never come. If you go even one step ahead, 4 is always there. The turn of 3 and 2 will never come. If you go one step ahead, 4 is already there. The turn of 2 will never come. If you go one step ahead, 4 is always there and 3 and 2 are now redundant. So guys, this is the feeling. Okay. This was the intuition I wanted to explain. People understand this part that yeah, the current guy, I put it at the correct place where it should come. But after putting it at the correct place, why am I removing all the elements less than them? Why am I removing 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 them? 5, 4, 3, 2. Okay, why am I removing them? Why am I removing them? Because it is very well known to me that first 5 is coming and then all these elements are coming, right? I told you in the property, now the first element comes first, then all these are coming. Okay, obviously this is not the exact order, okay, but it is guaranteed that first 5 is coming, then these guys are coming, then these guys are coming, then these guys are coming. Obviously after 5 somewhere 4 is coming. After 5 somewhere 4 is coming, you can see that. After 5 somewhere 4 is coming and 3 and 2 are coming in the middle. If some numbers are coming in the middle and you have written them after 4, it means they will never be used. Okay, after 5 4 is coming, I have inserted 4 by myself. Okay, but this is not valid. Why? Because I have written 3 and 2 after 4, right? But it violates one condition. It violates the condition that 3 and 2 should be coming after 4. They are not coming after 4, they are coming before 4. So if see guys, this, see, 5 4 3 2, this would be perfectly good. It would be good without any problem. You don't have to remove anything, but one condition should hold. What is that condition? This element should come first, then this, then this, then this. But in our case, first 5 is coming, then 4 is coming, but 3 and 2 are coming in the middle. If the guys smaller than you are coming in the middle, it means this sliding window 5 is the answer. Next sliding window 4 will be the answer. Means you got it, you got it. Now no matter how many times you increase your sliding window, till you reach this ending, 4 will only be the answer. 3 and 2 will never get the chance because 3 and 2 are smaller than me and they are coming before me. 3 and 2 could only get the chance if they were coming somewhere here afterwards. If they were coming afterwards, there would be a sliding window which would forget 4 and include 3 comma 2. Got it, got it, got the feeling. Got the feeling, guys. Just like Conor McGregor. So the thing is that 5432, there is no problem in this container. Everything is sorted perfectly well. But if you're writing 5432, this means that first the 5 should come in the sliding window, then 4, then 3, then 2. But what is happening in our case? 3 and 2 is coming before 4. 3 and 2 is coming before 4. So if 3 and 2 is coming before 4, you have to think of the future sliding windows. We make the container thinking about the future. आगे ये काम आएगा कि नहीं आएगा कंटेनर. तो अब 5 से 4 में तो आंसर 5 है. एक स्लाइडिंग विंडो आगे जाऊंगा तो 5 को भूल जाएगा, 4 आ जाएगा. If I go one sliding window ahead, answer will be 4. If I go even one more sliding window, answer will always be 4. 3 and 2 will never get the chance because they are smaller than you and they are front of you. Because they will never be used again. They will never be used again in any of the future sliding windows. In any of the future sliding windows. In any of the future sliding windows. Because say your current guy is B of I and some elements smaller than it exists in front of it inside the window. Their turn to be the largest guy will never come. To be the largest guy will never ever come. Will never ever come. Will never ever come. Will never come. This is the essence of this algorithm which no one was teaching their students. That apart from being sorted, it is guaranteed that the first element should come first, then 4, then 3, then 2. If it is not happening, 3 and 2 are of no use. If 3 and 2 are coming before 4, just think of the future sliding windows. हमेशा आंसर 4 ही होगा, 3 2 तो होगा ही नहीं क्योंकि छोटे है. अगर कोई 4 से बड़ा पहलवान होता तो मजे आते, तो फिर उसका नंबर यहाँ पर वो शिफ्ट हो जाता. So, guys, I feel that finally most of you understood. Okay, so now let's go towards the C++ code. You guys can see that nothing special has been done. Okay, I first come here. Okay, my container. First, I check, I remove the starting mess. You know, I told you first, before doing the main algorithm, you remove the starting mess. There should be no element at the start which is not in the current sliding window. So you check the index and remove all the guys who are less than equal to I minus k. See, removing the mess in the first while loop. Okay, if it is less than equal to I minus k, iq dot pop front. This removes the front guy. It will we keep doing this until all the fake gurus and the fake guys and the fake YouTube and LinkedIn influencers are removed from the start. Good, great, nice. Now what? Now what, guys? Now what? Now comes the main part. Whatever is your current guy, that let's say you are at index I. Let's say this is 4. So, and your current deque is looking like this. So you want to insert 4 at its correct position, but simultaneously, basically 4 should come here. Simultaneously, you want to also remove the elements which are less than equal to 4. So you start from the end. If you see the element less than equal to 4, delete it. See the element less than equal to 4, delete it. As soon as you see a guy, because this is in sorted order, descending. As soon as you see a guy which is greater than equal to you insert your 4 here. So from the back, you keep on removing all the smaller elements. See, that's what I'm doing here. If nums of q dot back less than equal to nums of I, q dot pop back. Once all the removals has been done from the end, then I put it at the back because now it is the correct position. Okay. And guys, if I is greater than equal to k minus 1, obviously I starting from 0, the sliding window बनने को तो k steps लगेंगे ना. तो अगर if your current I is greater than equal to k minus 1, now the answer is nothing but the first element of the container, which is q dot front. and you push it in your answer, and your job is done. That's it, guys. That's it. Congratulations, we did it. We achieved this feat. Amazing feat, actually. So, guys, in Java code also you can see deque integer array deque we are using. First, I have a container for this. I Whenever you have the container, now you imagine you have the container for the previous sliding window. Now the new current element is coming, but before that, whatever elements at the start of the container which are useless, whose index is less than equal to I minus k, which are not in the current sliding window, you remove them. Once the uselessness is done, you scroll below, and you want to insert your number at the correct position, but you also want to remove all the smaller numbers because they don't matter. They won't matter in your final answer. So you remove all the numbers smaller from me, from the back, then I just put my number in. Okay, because now all the smaller numbers are removed, so I am putting it at the end position, which is 5 ke baad 4. After 5 there was 4. If I greater than equal to k minus 1, that's it, job is done. Now I go towards the Python code, which is very very interesting. Okay, so Python code, guys, you can see on LeetCode that n equal to q equal to dq, I less than n, while q less than, see guys, I'm removing the extra guys from here. Okay, q of 0 means the first element of the container dq. Once the removing is the done, then from the back I remove the guys which are smaller than my current guy. Once I have done them, I can push my guy, it is at the correct position. If I is greater than equal to k minus 1, I hope you understand why greater than equal to k minus 1 I have written. Say k is 3, and this is your array from index 0, 1, 2, 3, 4, like this. So when your I is here, you cannot tell the maximum sliding window of size 3, because currently you are only process one element. When your I is here, then also you cannot do. Once your I comes here, then you can say your answer. So when I is greater than equal to k minus 1, where k is 3, so I is greater than equal to 2. Basically, from the day you start reaching here, you can say for this sliding window answer is this. For this sliding window so answer is this. I hope the visualization is clear. Ram Ram. With the name of God, you can achieve the impossible in this world, guys. Please have faith in God, plus good health, plus good mindset. Coming to the time and space complexity, this is also very, very easy. Nothing special you are doing. Each element, if you try to see this is called as the amortized time complexity. I have explained it in detail in my course, but for now, you should just see how many operations are happening. Okay, ignore these many while loops. Just see how many operations are happening in this container. You push each element only one time inside, and you remove the element from the start also for one time, and you push remove the element from the back also only for one time. So each element is getting pushed one time and getting removed one time. For pushing element it takes o of one time, for removing element it takes o of one time. So total o of 2n operations are being done. Total o of 2n operations are being done. 1n in pushing each element, no matter where you are pushing, but you are pushing it right at the back. One is removing. Sometimes you remove an element from start, sometimes from back, but you are removing each element only one time. Total 2n operations. Ignoring the constant, you can say O of n time complexity. Space complexity is also O of n. In worst case, your DQ might have a size of O of n, right, guys? That's why. So hope you guys like this session. Closing the meeting. Thank you, God. Always stay with me. Ram Ram.